For question number 30, it's given that the two balls are drawn. This is the part A. Two balls are drawn at random one by one with replacement from an urn containing equal number of red and green balls. And if you have to find the probability distribution of number of red balls, and also we have to find the mean of the random variable. So there are equal number of the red and green balls. So this is question number 30, part A. And let's say number of red balls is equal to number of green balls. Let's say this is x. Okay, so so number of red balls is x and number of green balls is x. So total balls in the urn is green plus red, which is equal to 2x. And probability of drawing a red ball is equal to x upon 2x, which is half. And probability of drawing a green ball is also half. Okay, now it's given that we have to draw two balls at random one by one with replacement. So the total number of balls in the urn remains same, and we have to find the probability distribution of number of red balls. So if we draw two balls, then if we do draw two balls and either none of them is red, so that means either it's zero, the number of red balls is zero, or either one of them is red, so that means either one of them is red or both of them are red. So let's say x be a random variable that denotes number of red balls. So x is a random variable, so that means x can take the value 0. None of them is red ball, either one of them is red or both of them is red. Now let's get the probability of none of them is red. That means first ball is green, and so that means first ball is green and also second ball is green. Now the probability of green is half and half, which is 1 by 4. So probability that none of the ball is red is 1 by 4. And what are the ways in which either one of them is red? So either the first ball is red and the second ball is green, or the first ball is green and the second ball is red. So probability of red is half into half plus half into half, which gives 1 by 4 plus 1 by 4, which is half. Now, probability that both of them are red, that means the first ball is red and the second ball is red. So this is red. So both of them are red, and probability of red is half into half, which is equal to 1 by 4. Okay, now our random variable was 0, 1, and 2, and their respective probabilities. Probability of 0 was 1 by 4, probability of 1 was half, and probability of 2 red balls is 1 by 4. Now, okay, this solves our first statement, and it's also asked to find the mean of the random variable. So we denote the mean of the random variable by E of, that is the mean of the random variable, and that is summation of EI into XI, that is probability when X is 0. So we have to do the product and then add them. So do the product and add them. So this is 0 into 1 by 4 plus half, 1 into half, plus this is 2 into 1 by 4. So 0 into 1 by 4 is 0. This is half, and this is also half. So half plus half is 1. So the mean of this is 1. Okay, let's move on to the B part. It says that A and B throw a die alternately till one of them gets a 6 and wins the game. So getting a 6 will make that participant win the game. So we have to find the respective probabilities of winning if A starts the game first. Okay. So in this case, because a die is thrown alternately by the two participants A and B, and one who gets 6 first will win the game. So we have to find the respective probabilities of winning if A starts the game first. So if a die is thrown, then probability of getting a 6 is 1 by 6. And probability of not getting a 6 is 5 by 6. So probability of not getting a 6 is 5 by 6. Now, let's say it's given that A starts the game. So probability of A winning the game. So it's possible that A throws a die and on the first throw he gets a 6, so he wins. So it's like probability of A winning the game is a probability of A getting the 6, that is 1 by 6. Now, if so, this is the first case. Now, if A doesn't get 6 on the first row, that means 5 by 6, not getting a 6. Now we have to make sure that the A wins. So now B is going to throw the die, and he's also not going to get 6. So this is 5 by 6. And now comes the turn of the A and he wins. So this is 1 by 6. Similarly, A doesn't win the game, B doesn't win the game, then the other possible way could be A doesn't win the game, B doesn't win the game, and now A wins the game. So this goes on like this. So this is 1 by 6, and this is 5 by 6, the whole square into 1 by 6 plus 5 by 6 raised power 4 into 1 by 6, and this goes on till infinity. And if you have a close look at this series, this is an where A is equal to 1 by 6 and the common ratio is 5 by 6 the whole square, and which is equal to 25 by 36. So here R is less than 1, and we know that to find the sum of the GP till infinity, formula is A, and because R is less than 1, 25 by 36 is less than 1, this is the common ratio. So this is 1 minus. So let's get the sum of this, which is A is 1 by 6, the first term, 1 minus 25 by 36, which gives 1 by 6. And this is 36 upon 36 minus 25, which is equal to 1 by 6 divided by 36 minus 25 is 11 by 36, which gives us 1 by 6 into 36 by 11. So the probability of A winning the game is 6 by 11. Now, to find the probability of B winning the game, it's easier because we have got the probability of A winning the game. So probability of B winning game is equal to 1 minus probability of A winning the game. So this is equal to 1 minus probability of A winning the game is 6 by 11. So this is equal to 11 upon 11 minus 6, which is 5 by 11. Okay, so this solves our question number 30 for both the parts. Let's move on to question number 31.